All right, we're back. So I've been gone a little while, went on a trip, and now I want to get back to this because we're very, very close. Just a little catch up. I created a test that will definitely fail because of duplicate names. So we're kind of like pretty sure that things just work, right? We've tested quite a few cases. They're not the most extensive of tests, to be honest, because I was still working through features whilst doing them. But we were at a point where we can start testing the more niche cases, and I do want to do like a full chaos test, like 5 files importing from each other, you know, all that that type of stuff. But for now, I'm on test 5 here of the names, the file names. What we have is this. So we have on the left mystruct, which imports from nested.mystruct, which is also called mystruct. This will break, right? Because I haven't handled the names. I haven't handled names properly. Well, I have handled names properly, not duplicate names, I mean. So with our test case, well, test case passes because I skip it, but if I don't skip it, we actually get a big recursion error on what is this? Struct types.dfs. Oh yeah, the depth first search, because it has edges, like circular edges, circles, and you can't. Is it circular edges? You should be able to do topological sort on circular edges, or should you? Yeah, you should because they're visited, but I think there's basically it just doesn't work quite like that. One thing that I kind of got started with is in types.go here, I have a name and then package path, so that we may end up differentiating it. This will be hard to find one case where it works all the time. But you know, let's just make the test pass and then come up with a more difficult test. I'm thinking like nested go and then nested again. But let's make this one pass and see what happens for now. Alright, so here, that's the test. And on the front end, we attach the name, and we can have a package path, which actually we don't really know, do we? We don't really need to know the path because we have module structs, list of name, to structs position, which is ordered, yeah, and then it says from file. I mean, we get from file, but on the what we could do from there. So actually, going to run the debugger to explore. Something I do like quite often. So we're going to toggle the breakpoint. We're going to continue. We have a debugger now, and really I just want to explore what it is that I get here. So I don't actually like this UI too much because I mostly choose the top left. Right, so here we have S, which is structs, stands for structs. This is our ordered struct, and it's from file min.go, so that's not going to be too useful. We do have the struct type, which probably won't have much, but it does have the ASD file. Now the ASD file might actually be more interesting. It has package, no comments, unresolved. What is it? Resolve, identify, and then position nested. Probably not. Scope. What's an ASD scope here? We get object, my struct. Yeah, okay. Declarations, name. Yeah, we don't actually get that much, it seems. Okay, so I might have to do it elsewhere. When we consume a directory, we then go through the file and consume the file. but we have the directory path, right, which we could do into consume file. Consume file returns a string. Where else are you used? So why do you return a string? It returns file name, okay. But it seems the return is not actually being used anywhere, is it? Consume file. Yeah, no, it's not, it seems. Package name. Okay. Well, you could return package name, I suppose, that's fine. But then you could also return the path. Oh no, but we know the path. From above. Yeah. Okay, cool. So that actually seems like the most sensible implementation of this. Package. Oh no, file name. No new variables on the left side. Oh yeah, of course, file name. Yeah, I mean we have file name a ton, so we really don't need that. We get package name, basically file name name, is that correct? Yeah, it is correct. So, but we do want a path. So we do, yeah, so the consume file actually pushes values to existing modules, which comes from the parsing state. So it says all structs here, and it's got this here, ordered struct types. Yeah, from file, we have a file. Let's add a package name. Your string, let's also add the package path. Hopefully we can, from one of those things, we can get, we will be able to get something that's unique from the path. I guess we kind of just go far back enough, even though that's pretty annoying to do. Well, okay. We set all structs here, here, here. Package name. You're just package name, and then package path. You should probably come from above. It's kind of weird doing it this way, but where's, oh, dear path. Okay. So now, if we continue on the debugging, we'll actually see that, what's going on here? Main.go. Oh, this is the code pass, so it's okay. Oh, sorry. Oh, what's going on? What's going on with the UI here? It's gone a little bit broken. All right. Wait, what the hell? What is happening? Sure, why not? I don't know what happened there. Let's continue. All right. Let's go in. Skip that stage, go in here. Oh, actually, at this point, we've already consumed some stuff. So we can go on P. P has module structs. We have main. We have a my struct that has package name main, and then package path, which is test/test5. Yeah, which is correct for this project. So nice. At this point, we'll be able to, we can tell it's test/test5, and then from file main.go, and the package name is main. There's a lot of information there, which we'll be able to use. Good. We pass, then we know that we can't have a duplicate name in the same package, so nothing else in this implementation will have to change. What will have to change is this here, the order struct list. First of all, we order them by order. Make notes, but before this, I'm gonna sneeze again. Oh. And again, oh god, allergies. At this point, we could have duplicate names across packages. And I guess the order I'm going to do this in is the same order we have above. Not good. Okay. Okay. I wonder if we should have, instead of name, some sort of ID, you know? Because I mean, if we have IDs, then the test will work. Let me try that actually. Let's try over here. I'm going to create var counter uint equals 0, and I'm going to say func get string counter, which is actually just going to use this global variable, counter plus plus, and then we're going to return val error, which is string converts at toy or I to a. And that doesn't even need an error. I to a, the counter, and just return u. You can be an int then. Okay, and this is gonna break every test. Like, I think that's. Well, actually, I didn't implement it, did I? Oh, but this would, yeah, no, this would be kind of a nightmare. But I think we need to do this. We need to turn the references into kind of uniquely identifiable. And then we sort out the names after. Unless there's something else that we could do. Solving duplicate names. I'm not sure. I'm actually not sure. I'm not super sure. Okay, well anyways, it should be pretty contained where we get the struct name. I suppose. So we pass the struct. Well, struct name comes to this module structs where are you used? Existing module structs, all structs here. This is in the consume file, isn't it? Yeah. Audit struct type, which takes the struct type and goes. Yeah. Okay, so struct name, which is gonna be the thing, but struct type there would actually would have the type, so I guess that's what I'm using. Typespec.name.name, yeah. So not you, struct name typespec.name.name, and I guess and you would be get string counter. Oh no, but then nope. I don't like this. Also can't seem to think of a much better solution, to be fair. So at this point, the front end is great, right? The front end works because the front end kind of splits things into a map of maps. So packages to, just packages, splits into packages, and then you never get duplicates inside packages. So that's that. But the thing is, when you refer to another struct, I need to like know which package you're actually doing. What happens if I have a nested? If I have nested.go, and the package here is just nested, and you have type my, what is it? Let's do my struct, which actually has world and you're an int, okay? And I go very nested dots. Yeah, it just works. And because this is nested up my struct, the name is just going to be my struct that I referred to. But I should also know which one you're referring to. So I should take a look at this last bit of the imports. Yeah, I take a look at the last bit of the imports, match it to this, and also we got to remember that you can do stuff like this and go. This is very much allowed, but I guess this would kind of solve that problem basically. So we look for this. We look for this in the import entry, and we say that now the name field is a bit more complicated. And I guess we could even just do something like, what's the character you're not allowed to name packages? I think a dash, nested dash n, nested, how does this work? Nested and it even leaves it there. So no dashes. Dashes are fine. Nested. Let's leave that there. And nested dot that, and then cool. Okay. So let's change the names. The name field at least. I reckon some of these won't be needed. I'll leave them for now. I'll actually move you up there together with that. You seem to be related. And let's go struct name. Struct name. Do I make this complicated? Yeah, okay. I'll make this complicated. The answer to that is always no, but I think this is okay. So I'm gonna have type identifier. I'm gonna have type name struct, and you're gonna have the name, which is a string, and we're gonna have func n takes the name, get package, returns a string. So it's gonna do a split strings dot split on the dash string n dot name, and you're gonna do this like this, and then it's completely fine to just throw otherwise. Get struct name, and you're gonna go 1. Yeah, that seems reasonable enough. And you're a name. Cool. Okay. We're gonna go name, struct name, name. It has name. Oh, we could do like a little factory method, I guess. Function create name package string struct name, and then it returns a name of the name of package package plus dash plus struct name. Struct name, what is going on? What are you complaining about? Oh, is that it? Okay. Create name, the package name, so actually, oh, but we could always have nested. Yeah, nested. Oh god, what to do about that? I guess we can store a little bit more in this name. We could have like path string. So we have package name, typespec.name.name, and then package path. Okay, and then I don't need. Am I using package name anywhere? No. Package path. Nowhere either. Did it build? Yeah, cool. So that's all fine. So, I mean, whilst doing this, we should still run all the tests. They all work. Good. Okay, so we created the name, and it's a bit more complex now. So the name. Oh, this still does. This doesn't solve the problem of figuring out the dependencies. Because, well, but it shouldn't here, actually, to be fair. It has to be. Oh, damn, this is hard. This is very hard. The dependencies should have. Okay, well, this here is unique, so. It's pretty hard. I'm going to go away and think about this one for a sec. Okay, that was a little bit quicker than I thought. Just had to basically write some stuff down, like there. And what the stuff says is we should take the names and be like, the name of a struct is always going to be the path, so it's going to be like nested / nested / this is the path to the package, and it's going to be the name, right? And we can do a dash here, or a colon, or whatever the hell. We can do Just stick with dash, doesn't matter. Change later on if you want, if we want. Like this, and then we have the first bit, and then the second bit. Cool. So this, I don't know why I did this way, but let's just do package path string struct name string, and you're just better now. Like this is just easier. What's the comparable interface? Can't remember. Golang comparable structs. Currently go comparable constraints used. Okay. You can go the comparable constraint is used to specify that a type can be used like this. String containing only comparable types. So person. This function is allowed because we only compare the age field, which is an int. I don't get it. How to compare to slice if to slice yeah. I mean, oh, what is this? Golang struct implement comparable? That's kind of what I want. Can a struct be comparable? So if I have this struct, zip also line is comparable. Structs are already comparable, but all the fields must be the same. Okay, so I think what we want is like already a thing. Great. So if I run this, then the top two, A is equal to B, yes, but not the bottom one. Great. So don't have to do anything extra. That's very nice. Okay. Cool. So what we're going to do is we're going to keep the name here. Yeah. Oh, but this runs into another problem that I didn't even think of, like the modules, the packages are going to be overridden. Wow. Yeah, wow. That's annoying. So I don't need struct name here, because at this point all structs, the auto struct type should only be used, like I guess is only really relevant when it's used with the above. Damn, hard problem. So let's get rid of you. Main.go is also going to be annoyed. Okay. But I don't actually have a test for this, to be fair. So what I'm going to do is I'm going to change this to be double nested world int single nested. That's just going to have double nested. That's going to have this dot double nested, and a main that's going to have nested dot single nested, and we're going to run this test here. That works, but it shouldn't. I think no. So that does work. But isn't the map overridden in the front end? If we consume the directory, then don't we override? Oh, because we go one by one. We can consume this directory. and then its dependence, and it all kind of just does things one by one. Almost one by one. Ah, okay, when that works. Okay, let's go back to having nested, double nested, nested, and then here nested, and then this should break again. Yeah, cool. Let's even add some spice and add you as nested. Great, you break. Now we're forced to think about this again. So maybe the module name's fine there, but what does need changing is what I thought needed changing. So back to the notebook. What we're gonna do is we're gonna damn. I think we still need, because we go through the keys, we still need to do the package name, not as file.file, but as a path. Where is file name used? File name goes from file. Does anyone care about from file? No. So 26, which became a bit easier. You're going to be the file path. Pretty cool. Actually, package path to make it easier. Oh, and it merges them. That's why it didn't break. Yeah. Yeah. Okay. Package path. Not package name, but the package path, which will be unique. That is now redundant. Okay, so consume file is no longer a file name, but a directory. So it's going to be the path and the main.go consume file. I mean, doesn't actually matter, does it? This one, because it's just for testing. So let's make sure that is fine. That didn't break anything. That does break stuff. Test nested depths. Run test nested depths. Could not find partial consuming directory. Oh yeah, because the yeah, I know why. But let's just do fm2.print line, the path to start with. Test, yeah, cool. So not the embedded struct here, past dependency field, that's the one, right? The dependency field is now gonna have a diff. Wait, where do you break? Could not find package struct after consuming the. Could not find package structs after consuming the. And line. Okay. Yeah, okay, yeah, it's here. So we do dep dependency imports. And actually we're gonna look, let's do fm2.println dep import. I forget what that looks like. And let's do fm2.printf percent plus v and slash, and then we're going to do p.module structs, and the keys Ah, yeah, I think they're exactly what we expect here. So if we change this to be dep import, does it work? Okay, that's less cluttered now, but it fails. And it fails. Why? Test nested dependencies. So this is 2 test 2. It goes. Oh, wait, 1, 2, 3. 1, 2, 3 shouldn't be included. Fair. So we have A here, yep. This shouldn't be included C. I guess, yeah, it shouldn't be included, but it's in the package, so it's going to be generated. Yep, that makes sense. So 1, 2, 3, 4, 5, 6, whereas the test file said 1, 2, 3. Wait, this is a bit too weird now. So we have the main struct, nested struct, and then D. And then shouldn't be included, nested struct, and then D again. Yeah, so we're generating 2 things again. Okay, let's go through it. Let's debug. Kind of maybe lost a little bit in complexity here. Let's go in. Skip you, go in here. Oh, at this point we already have some stuff. We have module structs, which has test/test2, which has the main struct. Cool. Nice. So then we go here, we go here, we go here, we go here. Let's jump in. Jump in. Which field are you? You're probably the nested one. Pass struct field type. You're a dependency. Yep. The struct name is nested struct. The imports at 0. Okay, well that's definitely going to be a problem. We have and then we say this. We consume the directory. So now we say that this here has the nested structure and this shouldn't be included. Cool. And then the package struct, nested struct, and shouldn't be included. Yep, cool. Wait, what is this? Because we did consume the, as we don't know the exact file, we should clean up because we don't want all the structs that we might not need present in our processing map, as they will make it into the final output. This, however, is concerned over efficiency. We are deleting it. We are deleting it there and perhaps rereading it in the future. We can optimize this a ton. Tone. Misspelled. Yeah. And it's not package name dot package here. This should be different. This should be the same dep import. Okay. Nice. Nice, they all run. Good. God, that's a lot of stuff. So let's go work in progress. Using paths for package names instead. Okay. Okay, one thing done. Debugger is so useful, man. During stuff like this, like you just need to run the program. Like you just do. Like when things get slightly more complicated, especially this. Like this is really like a big complexity thing, I suppose. But this is bad. Like this is I'm not sure about this. Okay. We've migrated over to using the paths for the module. For the modules, yeah. And now we need to take a look at the dependencies. Yeah, I know what to do. Yeah, cool. So pass dependency fields. Nice. Consumes the directory package. Oh, exactly what we were. Whoops. And then the name is the field name, and then the struct. The struct name. Why do you insist? Yes, but not quite. Because it's going to be more complicated. It's going to be. It should be the path where we are right now. Go here. Let's run. Duplicate names. Yeah, duplicate names fails. As it should. Okay. This time I don't really want to run this in the debugger every single time. I need to check some variables. Yeah, so it goes test/test5/nested. Good. And the name, because we've consumed that, we've made sure that we've consumed that struct, is going to be dep import plus a dash plus this. Now this will break other things a lot. Like, yeah, quite a bit. Because we're saying that this is this, but the name of the struct is not quite going to be that, is it? When we consume the file, we could. That's consumed there. When we consume the file, instead of this, we could say package path plus dash plus typespect.name.name. This will generate something quite funky, I think. Yeah, because now the come on. Big change. So it's going to be, yeah, test/test2. That's nested dash. Yeah, this is now the name. Okay, I mean that seems kind of correct. But I bet this is not the front end. This will be, no, it is front end. 241. 241. Why is what? Why 241? 260. How weird. That's weird. isn't it? That's not sure what happens there. Okay, let's do a breakpoint. Test nested depths here. So we go past struct, and we have ordered struct that has no, it doesn't have that. It has struct type and not file. It doesn't have fields. Isn't that weird? I feel like that's pretty weird. Oh, wait, what? Ordered struct type, and it breaks here, right? Yeah, you're done. You're what? That's so strange. Okay. And it is 241. Dot. Don't even know, man. Struct dot. Just print this, yeah. For now. 0, 0, 0. Yeah, one of them is just kind of balked. How weird. One of them is balked. So pass struct can be called from there. Not. Yeah, I mean the call is definitely here. In the package structs. Pass dependency field. We're using struct name. Yeah, I mean, yeah, this isn't great. Ordered struct. Yeah, you need to contain a path, I think. Package path. I say this again. But I think this time it's true. Package path, and then pass dependency field here. Struct name is going to be the ordered struct plus the package path plus a dash plus this. And then I can get rid of you, like so. And you are now crashing in another area. No, still the same. 244 163. Yeah, same thing. Let's just make this a little bit nicer. Okay. Struct type and file is nil. Package path is empty. So this is an error that hasn't been recovered. I bet. Like this is just empty. This just looks Okay. Yeah, it looks like it wasn't initialized at all. But when we say pass struct, we go ordered struct. Who passes this S to you? It goes from package structs fmt.printf package structs. See, it's like, yeah, I mean, it just looks like it was polluted by something. Yeah, here we have, yeah, you see, here we have a map. The main struct is all fine. And then we have a map with a nested struct, which is not so fine. Okay, let's stop fucking around. Let's just debug. Okay. I mean, you should have probably hit the other one first, but okay. What's in ordered struct? We have the package path test/test1. Good. Okay. Yeah, I mean, we can jump out of that. Pass struct field, yeah, let's do that. Pass struct type, you're going to go into a dependency one, right? Wait, did I jump too many? I think I jumped too many. Continue. Let's go. Okay. We pass struct, we have an ordered struct, yep. And then we're going to go here. If field.names is equal to 0, that means it's embedded. It is not. We go here. Nope. T is identifier. Name B. Oh, is this doing that thing where it runs the wrong? Oh, right. I can't put a breakpoint here without. Yeah, I get it. Yeah, it's running all the tests. It's not just running that one. Yeah. Okay. Now let's continue. I was wrong. Fatal. Oh, what the fuck? What is going on? You're done already? Okay. Fine. I guess. What? Toggle breakpoint. Toggle breakpoint again? Maybe? Okay, 6. Can you stop crashing? I know you crash, but just hear me out. Does it not compile or something? No, it compiles. But okay, I mean, there's something going on for sure. I'm gonna go past struct. Pass struct field. Pass struct field. Pass the type. Pass. You know what? Let's just toggle here. Hopefully it decides to work now. It doesn't work. Okay, my debugger has decided to go to sleep. Alright, that's really annoying then. That it has just gone to sleep, but it's got to do with the consuming stuff, right? It's got to be. Well, this is just one massive long debug session. Yeah, sorry about that, but hey, fmt.println typespec.name.name. Or actually, this entire thing. Go test that. So we go main struct, pretty cool. And then we get the map. We get this. The nested struct believes it's borked. Like, doesn't actually. Is it the tidying up? Because it's the English nested struct. Consume there. Path dependencies. The struct. What's the struct name? Oh my god, man. It has to be there, right? Okay. fmt.println printf package struct name. I bet, yeah, it's just not finding it, right? Probably. That's just yeah, it's not finding it. The package struct. Okay, just package structs then. It's not finding it. Package struct has a map to test/test2/nested, and I'm looking for println destruct name, which is there. /test2 nested. Oh, come on. Nested. There it goes. test2/test2-nested struct, but it doesn't include. Oh, is it not including the package directory? When it does consume there, the directory path. Oh, it goes for. No, that's not. I can't. Oh, man, this is annoying. Okay. Let's do a different symbol here. Eventually, you're going to consume both. You're going to consume this and then that. So, yep. But then it goes and it very confidently says test/test2-nested. Where it should really say test/test2/nested-nested struct. Ordered struct, package path. What's the package path? Maybe that's what's wrong. No, I mean that seems correct. Okay, I mean, after we consume the directory, let's just go for key value in the range package structs fmt.println kv. We have test slash. Oh god, my brain is just not working anymore. Test slash test2 slash nested dash nested struct. Okay, that's all fine. Shouldn't be included. And oh wait, where's the other FMT stuff? FMT.println. I'll get rid of you. You're fine. Okay. So I mean we have, that's cool. That's fine. Wait, there's something somewhere. FMT.println. FMT.printf. Yeah, it's here. Printf, get rid of you. Okay. So it consumes the directory and has the nested struct and it shouldn't be included. Perfect. And then it falls over. Okay. Falls over. Okay. Main struct nested. Okay, the name is correct. Consuming it seems correct. Okay, I'm gonna redo that one. Yep. And then just before it, let's do the struct name. And I think there I know where we are. Because it's not the name of the struct. Yeah, God, I forgot an entire massive bit of the code here, bro. The struct name is now way more complicated because it's not actually the ordered. It's not the current order struct package path. It's the get the actual path from the import. Very silly of me. Which we will fix in a bit because I have to go do something. Hopefully I don't miss this one. Don't forget it. All right, let's continue. It's a couple days after, but let's go anyways. So we did go with this approach of having a dash between the package path and then the name, right? One of the problems that this has is that it creates a lot of complexity everywhere, right? So if I search for this, we have quite a few places where this happens now, and this isn't very good because it's really repeated, and you need to have some kind of like tribal knowledge about how this works in the inside. But for now we'll keep it because I was worried. I want to get things working, and now I actually have this test passing here. So if I show you the backend code, what happens now? Right, what happens now is we use the same name. We use the name of the package path dash the struct, so that will work. Right, and then what we do, where is it? Yeah, it's over here. We get the name by splitting the namespace name, which is contains the package. And yeah, this you can see this is used in two places. Up here to make a name map, and then the name map is used in quite a few places. Name map is what we use to actually get the name of the struct when it's dependent on when other structs use that struct. And this all works. There we go. Pretty cool. But this doesn't actually solve the problem that initially I set out to solve, which is the duplicate names. It solves the nested. It has minus a struct and stuff, but doesn't solve the duplicate names. So actually now, oh wait, that was skipped. So maybe it doesn't work. Does not. Interesting, but does it fail for the right reasons? Dash run test duplicate names fmt dot. So we have quite a few print statements now, I think. So this one can go. Do that print the output. See that? Yeah, okay, cool. We're good. Where is this? Okay, cool. And this has, in our tests, we have nested, and then yeah. So I think this actually is fine, maybe. So we have nested, which contains one number, and we have nested, which is double nested. Yeah, this is fine. But they're all the same, you know, like the names are all the same, but it does work. So we need to find a way to unnest the names. And for stuff like this, where there's a lot of repeated package names, I don't really know what the best solution is. Right? Because I can imagine there being a lot of duplicate struct names. So actually, maybe let's start with that. Let's not have a package called nested. Let's go with just more nested. You are more nested. And here we're gonna have more nested. Oh no, not this. More nested from here, nested. So there's a couple of duplicate names. So I reckon what you could do is you could unduplicate the name by taking the package instead. But one of the things that's going to happen is that because it's this topological sort, that means that the priority then goes to the more deeply nested package, which it probably shouldn't. It should be the other way around. But we do have the map, so really this probably isn't that much of a problem. So the front end doesn't really change. It just doesn't have to change anything. But this get name might be different. So when we do make the names, we can do a check if it exists. So let's just first of all do. So we have get name. Yeah. So let's struct name. What's that name? Real name and exists, which is name map s.name. D.print line. This is struct name, isn't it? Yeah. Let's print line the real name and if it exists. That's what they're saying. False, false, false. Should that be true? What was happening there? That's that name as well. Oh yeah, this is. Wait. What's going on here? Struct name. Nested. Okay. So then. What was wrong with what we had before? Struct name here. So we call the function, we ask what's the real name? Oh no, the real name is gonna Yeah. So we actually go namespace name, and if it exists, this can actually go back to there. That's it. Okay, I'm all caught up. Let me actually change the terminal a little bit so you can see things a bit better. Okay. Doesn't exist. Namespace name also just, you know. Wait, well, I'm literally setting it down there though. Oh, but s.name is gonna. I've got things all mixed up the other way around. We actually need to check the. Yeah, we need like kind of another one of these, kind of. We need a doubly linked map. Yeah. Is there one of those in Go already? Golang doubly linked map. Linked hash map. This function that preserves insertion order. It's backed by hash table, store values, doubly linked list to store ordering. Oh no, it's not what I want. What I do want. Yeah, let's just do name map, and let's do maybe no, let's just do real name to name spaced, which is a map of string and string, and here I guess we can do another one of these. So yeah, but we're gonna merge the loops in a sec. So we go for the structs, we're gonna go the real name to the namespace name is gonna have the get name of s.name, and that's equal to s.name. That's it. Okay, cool. Then here we ask if namespace exists in the real name to name map, and we got namespace name, and if it exists, that's it. Oh, this, yeah. Get name s.name. Struct name. Very good. Let's go. Okay. So basically, in here, if it exists, another struct already has the real name. Let's try and change it to a package name. Let's actually do, yeah, let's do while it exists, before it exists. We're gonna say, we're gonna go back a slash. And eventually it will be correct. Like you can only go far back enough that you can always go back far enough that you will have a good package due to the package rules. I think func get name with package. We're gonna do namespace name string and then the level, which is an int. Say uint. Just say int. Yeah. If level is smaller than or equal smaller than 0, then panic should only receive positive int. Should I do that on the type level? Yeah, let's do uint. That's type level better. Okay. So we're gonna go strings.split. Split says also strings after each instance of sequence returns a slice of those substrings. Split after slices s into all substrings after each instance of sequence. we can split it on the slashes. So first of all, we get okay, split dash, which is strings.split the namespace name on a dash. So then we have the real name, which is split dash 1, package path, which is 0. Okay. And then here we go, and yeah, slashes split slashes. That's not very good naming. Strings that split the package path into the slashes. Actually, this might be something we can just test. Yeah. Maybe not on this file. Yeah, let's do this file. Func test split util. What do we need to? Maybe not. It's like pretty straightforward, to be fair. So we split on the slashes, and we're gonna go backwards. So var index equals the length of the split slashes minus 1, and we're gonna go var output and return output for I is equal to index plus I is bigger than or equal to 0, I plus plus. We're going to go output, and the output is actually not going to be plus or equal. It's going to be equal to, yeah, it's going to be equal to split slashes at I plus the output, because we want to put it before. And we want to go output of that plus, let's do a dash for now, and then plus real name, get package with slice. So we do this. We're going to go, oh, the levels. So we go smaller than or equal to level. No, we actually go index minus level. So like if there's 4 and then the level is 1, yeah, that makes sense, I think. Let's do an if for now. If it exists, then we actually go struct name is equal to get name with package of namespace name. I guess that we have it available, and we go level 1, and we go and do that print line exists, do that print line the new struct name. See what happens. It works. Why do you bork? That's what happens when I don't try and test stuff. Utils, just go test.go. Package main, func test, split t, that's the testing.t. Get name with package. We're gonna feed it nested slash name nested. Oh, it could be nested slash another. Let's go more nested dash struct name level. See what happens with 0. Don't actually know. t.log name. If name is not equal to, I guess if it's 0, it's going to be struct name, t.fail. Test split. And then what happened here was 253. Oh, it's not plus plus though, is it? It's going to be minus minus. Oh, if it's 0, bigger than or equal to, so yeah, if the level is 0, this is going to be the index, so we're going to do 1, right? So it's going to do +1 dash we're going to do the output as the real name. We can get rid of that. Oh, that's the dash at the end. Nice. Okay, now we do need to do a couple more. Was this t.run? I remember we can do this. Say green easy test, and then here this takes in a function with all of this stuff. Let's get a couple of those. Single name test, so struct name, and then 10, here we go, with a single package name test, and like this, and 0 struct name. Those should all like be pretty okay. Some of them fail though. And which one fails? Testing. So this is on 17. This is this one here, struct name. There's no package at all here. Okay, so here we go. I guess we can assume that this test case wouldn't happen because you would never get duplicates on single package. So this, no, but you would for others, for the more nested stuff. Yeah, so I mean, if you start with the more nested stuff, then you're always going to be okay. Oh, it's actually not, it's not trivial. We could order them by the number of slashes. Oh, but that's... Okay. Okay, you know, let's chill. Good. These are the only two, I suppose. But then here we should order by the number of slashes. So here they've been topologically ordered. As long as I don't change struct list, we'll be fine. Here's where we do the deduping logic, like right there. Before we do this, struct list. We're gonna have to create something else. Struct list at 0. It's gonna have a name. Yeah, they're gonna have names. Oh no, man, this sucks. But I think we probably just have to. Okay, so we're gonna need to create an array of length. Oh god, this is not great. Index to change, which is make of map of int. It's going to be the same length as struct list. There we go. Index to change. Names to change. All of this stuff can go up here. And you are a list of strings. No, man. This is weird. This is weird. How do we actually do this? What I am trying to do is I'm trying to go through this list, check the names, check the struct list, which could be in many orders, and you want to alter the names. It's actually not very straightforward. Not very straightforward at all. But it's just an array. This sounds like a lit code problem, actually, like an array lit code problem. And there's nothing like really. Oh no! If we get 2, they could eventually be the same. Oh, do we just take this? The less. I mean, I can. Okay, you know what? Let's start very easy. One test at a time, and let's go. Test to look at names. Exist test 5 nested. Okay, great. And then if it already exists, then actually what I'm going to do is I'm going to say that that's what the struct name would be. And let's go fmt.println. fmt.println name map. What do we get? We get. Oh, that's not very nice. That's also not great, to be fair. So we got test/test5 nested, which goes to test5 nested. Oh, which actually kind of works, except for the name. So this goes test5 nested, and the other one also goes test5 nested. Nearly. Close. But this is just a little bit weird. Yeah. But okay, this is fine. Let's just continue. But it seems like the output name when we do. Where do we do const? We do get name. Yeah, no, this should be name map. Okay. So yeah, test5 nested, test5. They all go to test5 nested. Well, that's not right now. Why do they all go to test5 nested? Oh, they start at test5? They should not do that. The sprint line, the struct name, and the namespace name again. So what we're working with. Yeah, I guess test5 nested. There is let's go for exists var level equals 1. And then we go level plus plus. We go exists. We go underscore question mark exists real name to namespace of struct name. If it does exist, we don't do anything. We continue. Do you work? Not really. Still doesn't. Let's get rid of you. Double nested. Go with string. Okay, let's get this one test out of the way. Okay. They're all going to test5 nested now. That's not okay. That's not what we wanted. Get name. Who uses get name? That's correct. Yeah, node name map should now contain them. So for key value in the range of name map, print line key and value. Okay, so we have the test5 nested dash nested goes to test5 nested, and this one doesn't. But why does it exist? Print line s.name and struct name. Okay. So we go. This just struct name. Like exists, yeah. Oh, but this is like really bad, actually. So as we add stuff on, then we need to change the name. Okay. Let's start up here. This just needs concentration. It's fine. We go name spaced exists real name to namespaced struct name. Okay, so we put the real name through and we get this namespaced out, and we go like if it exists, then we can't put another one in, right? We have to go and say struct name equals get name. Actually, like this exact same code here. Kind of. Nope. Nope. Let's go this. And here. Okay. S4 exists, not like this. We got struct name, get name with package with namespace levels exists is whether this new struct name exists. Then we feed it through. And then we need to feed the other one too. We need to go ahead and say that the name map, which is the s.name, is equal to the struct name, and you are also going to be struct name is equal to name. So yeah, there's our relationship there. And no, it doesn't work. God damn it, man. I can do that print line, namespace exists. Okay, it exists. Line new struct name. So okay, it went false and it didn't exist. Great. So we just say we continue. Great. There we go. Let's get the new struct name. It's nested struct, nested. Good. And then we set that through. Sorry. Okay, this is the key value. So the test/test5-nested goes to nested, and then that one also goes to nested. That's why are you doing that? What are you doing that for, bro? I thought we agreed we were doing that. Oh, it's this. It's kind of the reverse order I wanted it in. Oh wait, yeah, this is wrong now. That's kind of weird though, isn't it? So then somehow test/test5-nested went into nested. That's something, isn't it? The name. That's the new struct name. Wait, how does that happen? If you can't even like that's pretty weird. So we go. That goes to nested. This here goes to nested. What? That's wild. How? Oh wait, no. Up here it's fine. No, it's not. It's wrong. Quite wrong. How do you end up as nested? How do I feed this in and get nested? That's... No, that's pretty weird. It's actually pretty strange. I'm running out of weird characters to fill the stuff with. Oh, is it here? Where? Hold on. let's get the namespace and the struct name. I reckon it's there. Okay, so at the top we have nested, and namespace doesn't exist. So what happens there? Let's think. It goes in here. The name, if it does exist. So actually that just goes straight through, and it does this. This goes to nested. So it goes struct name, which is nested. The real name to namespace is assigned as .name, and then yes, the name goes to the real name. Cool. I mean, you know, maybe not cool, but all right, fine. Yeah, pretty interesting. Maybe I'll go think about this. Okay, so I think I've come up with a somewhat good solution. I would say it's fine. It's really nothing to write home about, but it's okay. And it's kind of messy, but basically what happens is, first of all, we have a lot of memory being allocated, but I keep this stuff. I go through the struct list and I create these names and these names to index thing, and I reckon this should probably like come underneath here. Makes more sense. Okay, and we assign names at a certain index for the actual struct name, and then the names to index, we take the original struct name, which is always unique if you remember, to the index. This will be useful later. What we then do is we sort the names, and the whole reason we don't want to sort struct list on names is because that's already sorted from topological sorting. We go here and we sort names on kind of an ugly function, right? We add the dashes and slashes, and we prioritize those because we want the top level structs to be the original names, whereas the very nested ones, you know, doesn't matter. Like, and also it's impossible to do the other way all the time, because you can get path conflicts. In my head it works. It's really hard to explain though. In my head this way is the only way that works. The other way is impossible. Not impossible, but it's you will get conflicts at some point. But maybe not. I'm just rambling. Anyways, after we sort, we go through the names. So just to show you kind of the result, names here. The result of this is we get the top level names first, right? And we go through them. We ask, right, what is your struct name? Remember this get name function? It just returns after the dash, which would break if the folder name has a dash in it, I just realized, but problems for later. We get the struct name, and a couple of things we do after. We grab the original index, and the original index is used there. So we basically say, right, what is the actual index from above there based on the name that you've given me? Let me grab the actual original struct from that list. This is a way of keeping a new list linked with the old one by the index and virtue of two maps. Yeah, that kind of makes sense to me. One goes to a name, then to an index, the index then to the actual list. This here is a map access, this is an array access. So the bottom one is basically instant, the top one is not so instant. But they're both O1 operations, even if the top one is much heavier. Then we do an ON operation. So this little thing is ON squared. And we ask if the slice, this is a set, right? So this can be improved and just be O1 to ask if the slice, which is used names, contains something. Is there a set in Go? You know what, let's ask. Golang set. Why does Golang not have a... There is a set. Is there a set? Golang collections. Does it actually not have a set? Yeah, we can implement a set, I suppose. But it doesn't. This, you know, it wouldn't grow that heavy anyways. But we will make this ON this here. Great. Then we say, right, let's do get name with package. Cool. Here we continue. And we do, and we increase levels. And we kind of go in a loop until it's fine. Then we go use names and we append and we continue from there. And this all works. This is great. Now, the really good way to test that this will work is, first of all, let's get a more nested nested.go, and let's go package more nested type more nested struct hello string, and let's go more nested, which is more nested dot more nested. And let's create another package inside there called nested. Package nested type double nested struct. Is there a double? Oh no, that's the only one. Hello int or something. And here let's go my double nested, which is nested inside here. Double nested and oh, you crash. No. Why do you crash? It crashes. Oh, it crashes on the front end. Doesn't even reach here. Why does it crash on the front end? That's pretty weird. 299. You ready? It's kind of strange. Which one made it mess up? I wonder. Oh, I know the one. Yeah, I know there's one function we didn't really do. Let's stay like this for now, and let's partially increment some stuff. I know, but I know exactly the one that failed. It was a hack I did. So yeah. So we get the more nested. We get nested. But actually, the more nested, I want to have the same name. So nested, and then here you are nested. See what happens? We get more nested. Perfect. Good. More nested, which has hello string. More nested hello string. That's correct. I was gonna say, I was kind of skeptical that wasn't in. And then the nested, which is double nested of string, and the more nested, which is a more nested, and then a const of the nested, which is in the top level or the higher level, main nested. Let's go. Okay, that's not confusing at all. Oh, finally. Feet. Basic duplicated names now work. Okay, you know what? I'm gonna end it for this video. This has been super long, and actually, there's two things that I need to go and do, and I might do a video now, but this video is too long already. Anyways, thank you so much for watching. I'll see you in the next one.